Alright, for quiz 7 here, we're going to have 2 problems with multiple parts. Just like with quiz 6, you'll have it split up into multiple parts here on the quiz. But then once we get to the test, it'll all be grouped together in one problem and not split up into the multiple parts. So you do want to make sure that you remember how to do each of these steps, whether I give you the specific steps or not. Because on the quiz, like I said, I'll have it split up into steps, but on the test, I will not. So you want to make sure that you're remembering how to do these steps for each of these types of problems. So first of all, we need to identify the null and the alternative hypotheses here. So here we have a hat company claims that the mean hat size for a male is at least 7.4. So remember, with the null and the alternative, the null hypothesis always has to have an equal to sign involved, and the alternative does not. And you do want to make sure you're writing these out with the correct notation. So in this case, we have the mean, and we're estimating, remember, in terms of the population mean. So we have our symbol mu there for our population mean. And we have that the claim was that the mean hat size for a male is at least 7.4, which means that the mean is greater than or equal to 7.4 if it is at least 7.4. So make sure you're reading those carefully of what it is in terms of an inequality sign. So we have greater than or equal to 7.4. And in this case, that is the null because it has an equal to part. And you do want to make sure to label which one is the claim as well, because that'll make a difference with your interpretations. So you have then that part is the claim, which means the alternative has to be less than the 7.4. So that's always the first step, and then the next step you need to decide what type of test you're dealing with, and then whether to use Z, T, or the chi-squared test here. So first of all, the type of test here, it would be one tail. In fact, it would be a left tail test. We know that it is a left tail because the alternative statement is a less than. So remember, you always look at this alternative hypothesis to decide which way it goes. Or another way of thinking of it is that it points to the left for the alternative, so it is a left tail, which also means, of course, that it is a one-tail test. So in this step, you don't necessarily have to state if it's left or right, but you do have to state if it's a one-tail or two-tail for sure. If you want to get more specific like I did and state which direction, you can. Otherwise, you'll be stating that in the next step. And then you have to decide whether we're using Z, T, or chi-squared. So anytime we're dealing with the mean, we're dealing with either Z or T. We only use the chi-squared test whenever we're dealing with the standard deviation or variance that we're estimating instead. So in this case, if we look at our sample size, we had a random sample of 25 hats. So that means that we're dealing with a T distribution here. T because that sample size is less than 30. So this one would be a T distribution. So we'll be using that T distribution chart for getting our values here in terms of our critical value or values. In this case, we're only going to have one critical value because it's only a left tail test, not a two tail test. Because that's what we're doing in this next step. So if it helps, you can draw it out, or you can just write it in terms of an inequality here. So here we're dealing with T distribution once again, and we're looking up for a one-tail test. So in that one, you're looking at the row on the top that has one tail, and then you're going over to your alpha there of 0.01. And then remember your DF, your degrees of freedom, is your sample size minus 1. So in this case, if you do the 25 minus 1, we get 24. So then if you go in the chart to that 0.05 column for one tail, and then go down to 24 for your degrees of freedom, we get 1.711. But since we're dealing with a left tail test, since we're on this left side, we want to use the negative of that 1.711. If it was right tail, then you would use the positive version, but since it's left tail, we would use the negative version of that. So make sure you're careful on that also. Lots of things to be careful of whenever you're doing these types of problems. So the next part is to find the appropriate test statistic. So that's where we're using the formula for your t, which just like with the last quiz, on the second page or the back page, which is that you guys will have for the quiz, we'll have the formula. So in this case, we're dealing with t and we're dealing with it for the mean. So we'd be using this second equation here that we have. So you have your sample mean minus the population mean divided by your sample standard deviation divided by the square root of n. So make sure that you are writing that in there correctly. If you don't have those down already, you'll want to make sure to do so. So let's write out what we'd have in this case here. So for our sample mean, for our x bar, our sample mean, we had was 7.25, because that's the mean we got from our sample of 25 hats. So you do that sample mean minus the population mean, which is the one we have from our claim, which was the 7.4, divided by the standard deviation from our sample, which was 0.25, and then divided by the square root of n, which was 25. And make sure if you're trying to enter this into your calculators all at once, you're going to need to group together the numerator and the denominator separately with parentheses if you're going to try and enter it all in at once. Otherwise, you can certainly do the top and the bottom separately and then divide them. So that way then you don't have to worry about the parentheses. Either way works. You do want to make sure you're practicing plugging those in though to make sure that you're getting the right answers there. This looks like in this case for this t, for this test statistic, we get -3 exactly, it looks like in this case. So then to decide whether we're rejecting or failing to reject the null hypothesis, but that depends on if this test statistic falls in that rejection region or not. So in this case, -3 is definitely less than a -1.711. So that means that we reject our null hypothesis. And if you want, you can just write your HO for your null hypothesis. You don't have to write it out in terms of words, but certainly do say what it is you're rejecting. You're rejecting the null hypothesis, because there were two different hypotheses that we had to begin with. And then just like normal, we want to make sure that we're also writing out our interpretation here as well. So let me go ahead and type this part in, since this part's a little bit longer. So here we have then that there's enough evidence at our level of significance of 0.05 to reject the claim, because remember your interpretation always has to be in terms of the claim. In this case, remember the claim was the null hypothesis. So if you're rejecting the null, then you're also rejecting the claim in this case. So to reject the claim that the mean hat size is at least 7.4. So the main thing there to include is that there's enough evidence to reject the claim. You don't necessarily have to include that it's a level of significance of 0.05 and what that claim was. but you definitely need to make sure that you're including what it is that there is enough evidence or not enough evidence for, depending on the phrasing that we have, whether we reject the null hypothesis or not. Underline the parts you definitely need to include. So you have to include that there's enough evidence to reject the claim at the bare minimum. That's what you would need to include there. And if you're still having problems with those interpretations, remember you can look on page 364 at that little chart that we had with those 4 different possibilities you could have for your interpretation based on whether your claim is the null or the alternative, and then based on whether you reject or fail to reject that null hypothesis. So make sure you're reviewing that before the quiz also. Like normal, if you're having questions on these, make sure you're asking before the quiz. You'll also see some of the stuff on the test. The next one is similar, but this one we're using, actually tell you in this one that you're dealing with the chi-squared test. So that means you're using that chi-squared distribution chart instead this time. And we're testing the claim about the population standard deviation. So here for our null and the alternative hypothesis, they're both going to be in terms of our population standard deviation. So you want to make sure you remember what that symbol is. That is the symbol sigma. So you will need to write those in there. And we're using the following information and assuming that it's coming from a population that's normally distributed. We have here that our sigma, our standard deviation, is equal to 1.35. So remember, equal to means the null. So in this case, the null is once again our claim. And then the alternative hypothesis, remember, is the opposite. So that would be a not equal to that same number, the 1.35. In this case, looks like I actually gave it to you in terms of the symbols. Some of them will be written down in terms of words. Some of them are written down in terms of symbols there. So make sure that you are careful whenever you're writing those out there. Write that a little bit nicer here. There we go, 1.35. And then we have our alpha is 0.05. We have a sample statistics of standard deviation. Our sample standard deviation is 1.05. And our N, our sample size, is 6. So here we have to decide if it's 1 or 2-tailed. Well, it's definitely 2-tailed here. If you want, you can just circle which one it is, or you can write it out. In this case, it's 2-tailed because we had not equal to for that alternative hypothesis. And then remember, if it was less than, it would be left tail. If it was greater than, it'd be right tail. But it's always that alternative hypothesis you look at to determine what type of test it is. And then to determine your critical values, it's a little bit trickier with the chi-squared distribution chart, especially whenever it's 2-tailed, because we have to look up 2 different values and we have to split it up into both ends of our chart here, both ends of our graph. Because we're going to have this end over here for the left tail, and we also have a right tail since it's 2-tailed. So we're going to have 2 different ends. And the chi-squared, there are no negative values for your chi-squared distribution chart. So you can't just find the one value and then make the other one negative like you can for the normal distribution and t-distribution charts. They're both positive, so you have to look them up both separately. So here to find one of the values, one way to do it is to do that 0.05 that we have for our level of significance alpha, divide by 2, since we're splitting it up into both ends. So one of our values we look up in the chart is a 0.025. And then to get the other one, we do 1 minus that 0.025. So then the other one that we need to also look up is a 0.975. And our degrees of freedom here, once again, is our sample size minus 1. So our degrees of freedom is going to be 5. So along the top, so where they have that alpha symbol, we need to go over to the 0.975 we can go to first, and then go down to our degrees of freedom of 5 there. So if we do that, looks like we get 0.831, and that's going to be the smaller of our two values, so that needs to go on the left side. It's just like a number line, you want to put the smaller numbers on the left side, bigger numbers on the right. So that says 0.831 there. So if you can't read that, make sure to write that down. It's 0.831. And then if we look up the other value, our 0.025, and go down to our degrees of freedom of 5, we get 12.833 there. This other one here is 12.833. And then we have to solve for our test statistic again, which remember the test statistic part is the formula. So here we have our chi-squared is going to be our test statistic value. And if we look at the formulas that I give you, we only have one of them dealing with chi-squared. It's that last one there. So here we have our sample size minus 1, which is also the same as our degrees of freedom. So in this case, it's 5. And then we have to multiply that times our sample standard deviation. Which we look back up for our sample standard deviation from this problem. It was the 1.05. So we're doing that times 1.05 on the top. But then you have to square it, because it's just a standard deviation and not a variance. If it was a variance already, then we wouldn't have to square it. Similarly, in the denominator, we just have a standard deviation there of the 1.35, that from the claim. And then we have to square it because it's a standard deviation and not a variance. Because remember, variances are already squared in the calculation. So if you're entering this into your calculator, once again, you want to make sure to group the numerator and the denominator separately there. So then here for your answer, looks like you should get 2.85. 2.85 there. So make sure that you're going through and calculating. Make sure you're getting the same answers. If not, make sure to let me know. Double check, plug it back in again, make sure I get the same thing again. And that's why I double check. Looks like I must have written it down wrong to begin with, so let's correct that here. You probably noticed that one of you plugged it into. Looks like it should actually be 3.02 here. I must have plugged something in wrong the first time I plugged it in there. So once again, that's doing that 5 times 1.05 squared, and then divided by that 1.35 squared. And then once you find that, remember you have to check to see if that value falls inside of your rejection regions. So it's definitely not less than a 0.83, and it's not more than 12.833. It'd be in here somewhere closer to this end. So it's definitely not in that rejection region because it's in between those two rejection regions. So if it's in between, that means that we failed to reject our null hypothesis. So do not just write fail to reject. You need to state what it is that you're failing to reject. And if you want, once again, you can use your H0 symbol rather than writing out the null hypothesis. So we're failing to reject that once again because our test statistic was not within our rejection regions. And then the last part, once again, is to then write out your interpretation. So one way to write that out here is that there is not enough evidence to reject the claim of the standard deviation equal to 1.35. And once again, the most crucial part that you need to make sure to include here with your interpretation is that there is not enough evidence to reject the claim is the main part there to include. So do not just write there's enough evidence or not enough evidence and leave it like that. Just state what it is there's enough evidence or not enough evidence for. So once again, the claim was the null hypothesis, so it's going to match up with whatever you had for the null hypothesis there. If the claim is the alternative hypothesis, then you're either supporting or not supporting the claim. So remember to look on page 364 once again if you need to go through and review some of those interpretations some more.